Hello and welcome back to Universe Sandbox 2. This is Spike Viper, and today we are going to do the exact opposite of the most popular video on this channel. Would that make it the least popular? I don't think that's how the videos work. I think this is going to be great. So, we're going to be realistically destroying Earth in Universe Sandbox 2. And before we start, a quick disclaimer: realistically does not mean that humans can physically do it, it just means that it could happen, okay? No, humans cannot make asteroids appear out of nowhere. I understand that you don't have to explain it in the comments, but we'll stop there. So, let's get started with the video. Okay, so for our first way to destroy the world, we are going to be using probably, out of all of these, not the most likely, but the most interesting. So let's put Earth down, because if we're destroying Earth, Earth has to be right there. And then let's add our closest neighbors, well, neighboring stars, Alpha Centauri. Now, Alpha Centauri is actually a binary star system, so we're going to have to put both of them down. And that's where we're going to actually get our problem from. They are about 4.2 light years away, 4.22, there we go, perfect. And let's plop them both down. So one of the most dangerous things in our universe is a supernova. They spread extremely quickly and release an amount of radiation that is just unfathomable. Okay, not gonna use that word. Unbelievable, because I can't speak. So let's say that one of these stars, Alpha Centauri A or Alpha Centauri B, got affected by an outside force and it threw off that binary star system so that they were to collide. They're going to release a massive supernova, and this is going to expand rather quickly. Now, there's 4 light years between this and Earth, so at the least, it would take 4 years if the material was speeding along at the speed of light. Thankfully, it isn't. Earth will be able to see the supernova in 4 years. So let's speed up to there. We can see right now it's been 5.6 days. Let's go up to 4 years. And we're at 20 days, 30, 60. Let's keep going. We're at 1 year-ish. We still don't know what's happened, and it's that large. 2 years. 3 years. There we go. That's over 4.2 years. So now we see that it just happened. We can't see that it's this big yet, because all we know is that there's a little dot in the sky and that there was a supernova in our closest star neighbor. Now, at this point, the scientists on Earth would already pretty much agree that it's game over. Depending on the severity of it, there's nothing you can really do. The amount of radiation is just ridiculous. However, if we were to find a way to save the Earth, we do have a lot of time, because you'll see that even though it's been 5.5 years and it looks that big, it's going to take quite a while for this to actually reach Earth. So here we go. This is the time we have. It's been 20, 30, 35, 40 years after the first explosion, and it looks like a little bit of the radiation is starting to hit Earth. Not the massive amount, but we're already running into problems. This amount of radiation would kill off most small life and pose large problems for the rest of the world. Probably the most interesting effect it would have is it would completely strip off the Earth's ozone layer and start ionizing the atmosphere, which would basically create a ton of smog that would choke the entire planet out, and that's going to happen about now. This is that point, and it's going to continue going towards Earth and flying past it, but Earth is now dead for all intents and purposes. There is no life left. It doesn't look like it really affected the surface much, but it's dead. It's kind of frozen because I didn't put it around the sun, but we're ignoring that. We're ignoring that fact. So let's go on to our second way. So our second way is obviously going to be an impact, because it's just so easy to destroy the world with an impact. Things even quite small will do a lot of damage. And if we just grab a random asteroid, let's see how large this is. It looks very small compared to the Earth, but what matters is that it's 29 kilometers across. The asteroid that knocked out the dinosaurs was 10 to 15 kilometers across, so that is a huge issue. And it is going to wreak havoc on all of the life on Earth. Now, I know this is called Destroy Earth, so this obviously isn't going to destroy the Earth, it's just going to destroy the life on Earth. So how would we actually go about destroying Earth as a whole? Of course, you can see that that little collision has done a ton of damage. Shockwaves reaching around the continental United States, and the impact crater is quite large. It's also raised the surface temperature of the Earth quite a bit. But even if that was enough to throw smog into there and kill all the animals, we need something slightly more to completely destroy the Earth. And for our purposes, we're going to just have the moon fall. How would it happen? Not sure. Maybe something... how are we going to make this realistic? For our intents, we're going to put the moon a little bit closer, much closer than it actually is, so that it's easier to see. And we're going to actually have another object hit the moon. Let's say a small but not quite tiny object. I don't think that's going to be enough. I think that may be enough. If we have an object hit the moon is much smaller than the Earth, so it doesn't take as much of an impact to slow it down. So let's say we've got Dione, and it's going to hit the moon with quite a bit of force. It is smaller than the moon, but the amount of force is going to affect the moon's orbit, and it's going to push the moon in the opposite direction its orbit is currently going. If this were to happen, obviously the moon's orbit would be severely affected. And we can see its orbit is actually shrinking, although I'm not sure if that did enough. It seemed to only be a grazing shot, whereas we really wanted more. The material thrown out from that collision is certainly going to give Earth a bad day. But just for the sake of this, let's say that it did kill the speed on the moon. And we're just going to set it to, like, 0 for our purposes to make this easier. Surprisingly, none of the debris hit Earth. The moon actually acted like a pretty good bodyguard. It took the entire impact and blocked anything from hitting the Earth, so good job, moon. But now the moon itself has been knocked out of orbit, and it is going to hit the Earth with astonishing force. It looks like we're going to be hitting Mexico first, and bam. It would not take long for this event to destroy the world. As you can see, it's only 30 times faster than real time right now. It's only been 2.5 days, and most of that was spent with us setting up the simulation. The oceans are evaporating, the surface is turning into magma, and altogether, it's a bad day for Earth. Oof. Yeah. No, that wasn't good. There's a tiny bit of water. Maybe life could have survived. Some kinds of life may survive this. And the water still being there is actually pretty good for life. There are some bacteria that live in volcanoes and in very sulfurous environments, but I'm not sure if anything would be able to survive the severity of this. It's 600 degrees Celsius on the surface, and that's just an average. Even though the temperature is decreasing rather rapidly, which we can see right here, and it's decreasing very rapidly, and soon it will just freeze because no sun once again. But let's go on to the next thing, and our last one is going to be a little bit more far-fetched, but it's another thing that we really wouldn't be able to control. That's going to be a pulsar aiming at the Earth. So there are pulsars out there. They aren't completely understood, but for the most part, pulsars are an issue. And what they do is they are kind of a form of star that has such a serious magnetic field that it shoots out ions and material out the poles of the star, and if a pulsar happens to face you with that ray of material shot out, you are in a lot of trouble. So we've got this pulsar here, and it's turning. So this is what makes them so dangerous. If it's turning, and we're going to position lock Earth because Earth is going to be sucked up into this. If this pulsar is turning and it's close enough to Earth to actually hit it with that ray, if it were to turn towards the Earth, we might as well say goodbye. The amount of material, it's kind of like a supernova being shot at your face. It's not quite as much material, but it's directed extremely, it's very concentrated. And so if it's pointing towards you like this, it's not good. It's bad. It's very bad. Okay, so next off, we're going to simulate something actually really similar, but a little bit more serious. What if our own star went supernova? Now, we know this isn't going to happen, but if it were for some reason to happen, it would definitely destroy Earth. There's no real lack of consensus there. So let's just explode the sun very quickly and see the effect this has on Earth. Now, the sun is about like 8 light minutes away from Earth, so fun fact, the light you see now hitting the ground, it was sent from the sun 8 minutes ago. However, that means that we have a bit of time. I mean, 12:01, 12:02, 12:03. Because this isn't moving at light speed, it would take 8 minutes for us to know that it happened, and 8 minutes for a lot of the serious radiation to hit us. How's Earth doing? Yep, that serious radiation is hitting us, and it's causing the temperature to go up very quickly. The temperature on the planet is already at 60-70 degrees Celsius, and very soon the actual physical vaporizing material is going to hit Earth and just completely melt it. And now it's 100 degrees, and now it's 200 degrees, and now it's 300 degrees, and it doesn't look like it's ever going to stop. It's actually speeding up as more and more material smashes into the surface of the Earth. Now we're in the thousands of degrees, and the ocean does not like that. Actually, the rest of the planet doesn't like it either. And now it's glowing. We're melting, very quickly melting. And we are actually being vaporized. That is the actual rock of the Earth being turned into a gas. And Earth doesn't exist anymore. Oof. Yeah. That's why it's very good that that's not going to happen. Because it's a very... At least it's a painless death. I mean, just instant vaporization of the entire solar system. How's Jupiter doing? Jupiter has a little bit more mass to lose, so even though Jupiter is like at 26,000 degrees, it's actually keeping it together from the amount of gravity pulling its material down. So it looks like Jupiter may actually survive this without too much damage. I mean, there were probably a lot of chemical reactions inside, because when things are this hot, lots and lots of interesting things will go on, but it looks like it wasn't vaporized, which is very nice. Maybe it changed color or something because of the reactions on the surface and underneath. But very fun. It looks like a lot of the outer planets actually did survive. Jupiter, Saturn, I see Neptune. Very nice. Very nice indeed. Very proud of you. Good job, planets. Yeah. Not good. That would not be good.